All right, hey you guys. It's Monday, October 5th. We're going to try and get back on track here just a little bit, get things kind of back going under some semi-normal circumstances here. This will be kind of our normal for this week. Despite how I may sound, I actually feel quite a bit better than last week. Last week I was one sick human being. Now I've kind of just, it's sort of evolved into just a regular old head cold. So I'm a little congested, got kind of a cough. I'm sure the cough will interrupt me here in a little bit, but that's okay. My plan for today, I know some of you guys have turned in numbers 1 through 4 on the sine and cosine worksheet. Some of you have turned in all 8 on the sine and cosine worksheet. That's all fine and well. It's not a big deal. What I want to do today, though, is just get us kind of back on track. So I'm actually going to go through 1 through 4 with you here. That's going to suffice as our notes. And then if you are one of the people who has not turned in the assignment yet, if you are still struggling with it at all, or if you just have to do 5 through 8, because I know I think I mentioned on Wednesday of last week to the sub just to have you guys work on the first 4. If you still need to get those done, then hopefully this will clear up any lingering confusions. Okay, so you can see I'm actually not going to do 1 and 2. You can see here they're very simple, or very similar, I should say. One's a sine function, one's a cosine function. They both have a coefficient in front of theta. So on number 1 it's a 2, on number 2 it's a pi over 2. And they both have an amplitude adjustment because they both have a lead coefficient. So it'd be kind of redundant to do both of these. So we're just going to do 2, and then we'll do 3 and 4 as well, you guys. All right, so you guys kind of just use these, or use this video to check the ones that you already have done, and then hopefully you won't have any confusions. You'll be able to finish things up. So like we kind of had mentioned before I got sick last week, the first thing that we want to look for is we want to look for our periodic adjustment. All right, most times it takes 360 degrees or 2 pi radians to complete one of these waves. But that changes if there's a coefficient in front of theta. So in this case, whatever the coefficient is, that's what we divide 2 pi by. So we divide 2 pi by, in this case, pi over 2, which of course means that you're just going to multiply 2 pi by the reciprocal. So instead of trying to divide there, we're going to take 2 pi times the reciprocal of pi over 2, which is 2 over pi. Basically what happens, and this is kind of a weird one, but what happens is the pi's change, and literally we just are left with 2 over 2, which is 4. So sometimes that kind of freaks people out just a little bit. They're like, well, I wasn't quite ready for that. I don't know exactly what that means. Well, basically all that means, you guys, is that your first 4 increments here are literally just 1, 2, 3, 4, and then to do your second wave you go 5, 6, 7, 8. So kind of a weird thing that does not happen very often, but we actually end up rescaling our graph the way that we're used to scaling our graph, which is by 1 single unit. Okay, don't worry though, that'll all work itself out, not a big deal. Then we get into our phase shift, our vertical shift, our amplitude adjustment, and we're not going to worry necessarily about a reflection, even though there is a reflection on this one. Okay, so we kind of talked about last week the fact that if there are no parentheses, then there is no phase shift. So we would just technically say there is none on this one. There's no phase shift. There's also no constant at the end, so there is no vertical shift. And then the amplitude is -2. But basically all that means is that all we do is, instead of going where we typically would go up 1 unit from our midline to get our wave, now we would just go down 2 and vice versa. So this is a sine wave. The sine wave starts at 0, 0. And then basically for every increment it goes up, back down, down, back up. But here, instead of going up 1, we're going to go down 2. So I need to configure my graph here so that I can go down 2 units, back up to my midline, up 2, I'm sorry, my graph got kind of off there, but I'm going to go like this, back up 2, back down 0. So this is the first interval, or the first period of the sine wave, and then we just replicate that, back down 2 units below, back up to the midline, 2 units above, and then back down to the midline. So this one was actually super simple because there was no vertical shift, there was no phase shift, or there wasn't too much to this one. Really all that happened was we had to scale our graph differently than we're used to, and then we also had to change our direction of our wave. All right, the amplitude adjustment adjusted that. Okay, 3 and 4 were a little bit more involved, so I just got to make sure you guys take a peek at my phone here, make sure this is still all visible. Number 3 was this, another sine, y equals, okay, no amplitude adjustment on this one, it was just sine of theta minus 2 pi, plus 2. All right, so a little bit more involved on this one, and then I believe number 4 is the most involved, or the most added stuff on it, okay? So our periodic adjustment only happens if there's something different. So here we actually just say our period is 2 pi. We're not going to rescale anything. It's going to take us 2 pi radians to construct one whole wave of the sine. Okay, so here's 1, 2, 3, 4, that's 2 pi, and then we just start cutting in half, right? So basically the generic radians are pi over 2, 3 pi over 2, and then every one of these is just 1/2 of a pi. So this would be 3 halves, 4 halves, 5 halves, so 5 pi over 2. 6 halves would be, let's see here. Oh, sorry, jeepers. I've got a little bit of brain fog as a result of my sickness here. That would obviously be 3 pi, and then 7 pi over 2, and then 4 pi. All right, so we got to scale or label our first 8 intervals here. All right, so now this one's going to be kind of a little bit weird because there is a phase shift here. All right, so there is a phase shift. The phase shift, you'll remember, is the opposite of whatever comes after the angle theta. So the opposite of negative 2 pi is positive 2 pi. The phase shift is positive 2 pi divided by the coefficient, which in this case is 1. So here's what's kind of weird about this one. Instead of our first point being at the origin right here, because that's where the sine wave always starts, is at 0, 0, this is telling us to slide our entire thing over to right here. So we will, there's a phase shift or a horizontal translation of 2 pi radians. So we're going to do that, but what we're going to see is it doesn't stay, it never says what two periods to draw. So we're going to see how even though it's telling us to slide, we don't have to draw just this one and this one on the usual one. It can be any two. So I'll show you what I mean by that in just a second here. But before we can put that point, we do have a vertical shift of 2. So basically that means my midline is actually going to be up 2 units. Okay, so I've got this imaginary line. So basically what I was just saying was instead of our first dot being at 0, 0, the phase shift says slide it over 2 pi, but then the vertical shift says also slide it up 2. Okay? And then we have no amplitude adjustment. Our amplitude here is just 1, like it always is if we have no lead coefficient. So what you're going to see here is your sine wave is going to look pretty normal, actually. We're going to go from here, we're going to go up 1 point above the midline, back down to the midline, 1 point below, and then right back up. So there's one curve. That would technically be the usual one that's over here from 0 to 2 pi. But now we have options. We can either keep going in the right direction, or, like I said before, it never stipulates where exactly which exactly 2 periods we need to do. So we could, just to keep it on our graph, we could just do it right back here. So we're back down below the midline, back up to the midline, back above, and back on the midline. So in reality, because it was a perfect phase shift of over 2 pi radians, and that's exactly the length of the period, we actually can just like draw that one over here and then backtrack to get this one, and it looks exactly the same. Okay, so that one was a little bit weird because it ended up being relatively simple. Okay, all right, let's look at one more, and I believe, and I'm hoping, number 4 is a cosine wave. It is. And by the way, I should mention that once we get done with today, once you guys all have your your assignment officially submitted, we are going to move on to other waves and see what the other graphs of these functions look like. So that's kind of what we're going to spend our time doing this week, is basically just all the graphs. All right, but at any rate, let's finish number 4. Number 4 says y equals 2 times, so there is an amplitude, 2 times cosine, and then there's a period adjustment, it's theta over 4. But there's also going to be a phase shift because there is a plus pi over 2. So we're going to have a couple different things in play here. Amplitude adjustment, phase shift, and periodic adjustment. No vertical shift. But anyways, we'll just go through and do it. The length of the period here is 2 pi divided by 1/4. Okay, so it's technically theta over 4 would be 1/4 theta. So this becomes 2 pi times 4, or 8 pi. And that kind of freaks people out sometimes, like, oh man, that's huge. Like instead of it being 2 pi, it's actually 8 pi. But that's actually kind of a good thing, as you guys will see if you haven't already figured it out here, because all that means is that it's going to be easy for us to label our intervals. We go 1, 2, 3, 4. Usually it takes 4 intervals to make one wave, but those 4 intervals now need to span 8 pi radians. So half of 8 pi is 4 pi, half of 4 pi is 2 pi, and like I said, this just makes labeling easier. All these individual tick marks on our x-axis are 2 pi intervals. So just keep adding 2 pi, 10 pi, then we've got 12 pi, 14 pi, and 16 pi. That should get us there. Okay? Before we go and construct this here, actually, I'm going to make this one just a little bit bigger because they're, well, no, never mind. Here's 1, here's 2, here's -1, here's -2. All right, so the amplitude adjustment of 2 means that instead of my cosine graph starting 1 unit above the midline, it's going to start 2 units above. But instead of just putting a dot right there, I have to figure out how far I need to slide that initial point left or right. So that is my phase shift again. The phase shift is the opposite of this constant, so negative pi over 2 divided by whatever this coefficient is. So divided by 1/4. So this becomes negative pi over 2 times 4 over 1, or those will cross simplify, negative 2 pi. So, like I mentioned, that initial point would have gone up here at 2, because cosine wave starts above the midline, but the amplitude adjustment means it's going to start 2 above. But I actually need to move this whole thing. I need to construct or backpedal just a little bit on my x-axis here, because I need my graph to actually start at negative 2 pi. So it's actually going to start right here at 2. Okay? Because again, we already talked about the fact that there is no vertical shift. Okay? My amplitude just adjusts where my starting point is, so my amplitude is 2, and now basically we just do whatever the curve tells us to do, right? The cosine curve starts above the midline, then goes to the midline, then goes below. So every time, if my graph started 2 above, then it needs to go 2 below every time it goes below. So there's 2 below, back up to the midline, back up to 2 above, and then we just kind of curve it. Okay, so here's what the cosine curve looks like. One period of it anyways, and then we just need to carry that on back to the midline, back below, back to the midline, back above. Alright, so there it is. And it's a lot of repetition, you guys, it's a lot of the same thing, but once you get comfortable with the process of, you find your length of your period, you use that to break apart the first 4 markings on your x-axis, and then you carry those to the next 4. Then you realize that, the phase shift and the vertical shift just impact where you put your initial point. Once you get your initial point, you're pretty well golden, as long as you remember that the sine wave, starts at the midline and then oscillates above and below, versus the cosine wave starts out above the midline and then oscillates kind of in the same fashion, back to the midline and then back below and stuff like that. Okay, so what I want you guys to get done for today, if you've not already done it, is I want you to finish up 5, 6, 7, and 8. You can submit them either on here, or you can submit them on the one that you already turned in. If you already turned in all 8 of them, then don't worry about it. You're good. I'll find them. Not too worried about that. But I just want to make sure that everybody gets all 8 of these problems done and it makes sense before we actually move on to the cosecant and secant waves. And then obviously the same thing for tangent and cotangent, okay? So shoot me an email if you have any questions today. I'm also going to be by my computer all day, so if I do need to, like if you guys run into a big question, like there's this major question that a lot of you have, just either send me an email or request a Google Meet, and I can pop right into the classroom, and I can basically do the exact same thing from my phone here. I can meet right onto the board, and I can walk you through whatever question you might have. Maybe we won't have that issue today, but maybe as we move forward with some of these other curves, we might have that happen where I need to just kind of pop in while you guys are working. I can pop either onto the smart board, sub can pull me up there, or I can pop onto your individual computers. One thing I do want to mention just real quickly before I forget is I'd like for the sub not to have to show you guys necessarily the videos. So if you guys can all just make sure you have headphones moving forward, that way you guys can just kind of log on, hop onto the video on your individual device, watch the video, and then do the homework. Then the sub doesn't have to have the volume blaring or anything like that, and not the whole school doesn't have to listen to me teaching calculus during 7th hour. So try to by tomorrow, but for sure by Wednesday, if you don't already, just have a set of headphones that you can just plug in, so everything can kind of be self-contained. All right, that'll make, I think, our life a lot easier this week as we have to do this thing remotely. All right, guys, like I said, if you have questions, shoot me an email. I can either pop online and do a Google Meet with you, or I'll just respond via email if you have questions. All right, have a great day, guys. We'll talk to you later.